electric dipole placed in uniform magnetic field is given by tau equals to Pe sine theta. In vector form, it is P bar cross E bar. Next, same torque, two conditions we are writing. Case 1. Condition for maximum torque. Since tau equals to Pe sine theta. For maximum torque, sine theta should be maximum. What is maximum value of sine theta?
1.
1. For which angle sine theta is 1? 90 degree. Sine theta is 1 for 90 degree.
Yes, sir.
Therefore, torque is maximum when dipole is perpendicular to field. Perpendicular to field. Torque maximum value will be P, because sine theta maximum is 1, that is at 90 degree. Right, case 1 for maximum torque. Yeah, completed writing. Condition for maximum torque.
Yes, sir.
Right, case 2. Case 2. Condition for minimum torque. Case 2. Condition for minimum torque. Minimum means zero torque. Condition for minimum torque. Case 2. Condition for minimum torque. Since torque is P sine theta, for minimum torque sine theta should be 0. Sine theta is minimum. That means sine theta is 0. Sine of 0 is 0. So theta should be 0 degree. Therefore, for minimum torque, the electric dipole must be parallel to the direction of speed. Minimum torque equals to 0. Copy second case. So this completes our torque expressions with maximum and minimum condition and its value. Maximum torque is PE, minimum torque is 0. Maximum will be when axis is perpendicular, minimum when axis is parallel. Okay.
Yes, sir.
Now two very important derivation for college exam as well as for entrance. Derive expression for electric field intensity at any point on axis of electric dipole. Derive expression for electric field intensity at any point on the axis of electric dipole. What is electric dipole? Two equal and opposite charges separated by finite distance is called electric dipole. We are interested in electric field intensity due to this dipole at any point on its axis. Axis means line joining, negative charge and positive charge. So this is nothing but axis, this line. Consider an electric dipole consisting of equal and opposite charge minus q and plus q at A and B, separated by finite distance 2L, OB the center of dipole. Therefore, OA equals to OB equals to L. Let P be a point at a distance r from center O on the axis of dipole. For negative charge, what is direction of electric field? Inward or outward? Hello? For negative charge, what is direction of electric field?
Inward.
Inward. So electric field intensity due to minus q charge at point P will be given by E1 equals to 1 upon 4 pi epsilon naught q upon distance from A to P, that is AP square. So E1 equals to 1 upon 4 pi epsilon naught q upon AP is R plus L the whole square. It is directed inward. Still this any doubt?
No, sir.
Can you just suggest me what will be direction of electric field due to positive charge at point P?
Outward.
Outward. Now clearly you can see these two intensities are in opposite direction. Result will be different. See, every time opposite doesn't mean it will become zero. Equal and opposite zero. Now I will say resultant intensity will be difference. Larger minus smaller. So after getting E2, we'll check who is larger and then larger minus smaller is resultant intensity at P. Please draw only diagram till there. Diagram over?
Yes, sir.
Right. Consider an electric dipole of consisting of two equal and opposite charges of magnitude q, comma, separated by finite distance 2l. Separated by finite distance 2l. Let O be the center of dipole. Let O be the center of dipole. Therefore, OA equals to OB equal to L. Let P be a point at a distance R from center of dipole. P be a point at a distance R from center of dipole. The intensity at point P due to minus Q at A is given by E1 equals to 1 upon 4 pi epsilon Q upon AP square. It is directed inwards. If done, then say, because then we have to get E2 and then resultant. Completed till it is directed inwards.
Done, sir.
So we got intensity at point P due to negative charge at T. The intensity at P the intensity at P due to charge plus Q at P is given by E2 equals to 1 upon 4 pi epsilon naught Q upon Bp square. Therefore, E2 equals to 1 upon 4 pi epsilon naught Q. Now, see what is B to P distance. From O to P, distance is R. O to B, distance is L. So, what will be this BP distance? R minus L square. Hello, is it R minus L?
Yes, sir.
Yes, sir.
And it is directed where? Outward or inward?
Outward.
Outward. It is directed outwards. Thus, resultant intensity at P, comma E equals to resultant intensity at P, comma E will be E2 minus E1 because E2 is greater than E1. E2 greater, इसका denominator छोटा. Say 4 by 10, 4 by 100, who is greater?
4 by 10.
4 by 10
4
is,
by 10.
so both E1 E2 का एक टर्म सेम है. Denominator of E1 was R plus L square and E2 R minus L square. So denominator छोटा मतलब answer will be मोटा, therefore E2 minus E1. So E becomes 1 upon 4 pi epsilon naught Q upon R minus L square minus 1 upon 4 pi epsilon Q upon R plus L square. Taking 1 upon 4 pi epsilon Q common. E equals to 1 upon 4 pi epsilon naught Q in bracket 1 upon R minus L square minus of 1 upon R plus L square. So E is 1 upon 4 pi epsilon naught Q R plus L square minus of R minus L square upon, I just cross multiplied, R minus L square into R plus L square. Please copy. Again, once you complete, please say completed till last line. Okay, we got intensity 1 upon 4 pi epsilon naught into Q R plus L the whole square minus of R minus L the whole square upon R minus L square R plus L square. Now we have to simplify this to reach to the final answer of intensity at any point on the axis of electric dipole. E equals to 1 upon 4 pi epsilon naught into Q R square plus L square plus 2LR. This will become R minus R square minus L square plus 2LR upon. This is like A square minus B square. So I can say A minus B, A plus B, दोनों का square common I am taking outside. This time clear what I did? Power 2 I have taken outside common. Okay. Okay. Like say it is A raised to M, B raised to M. You can write A into B whole raised to M. Correct?
Yes, sir.
R square minus R square. L square minus L square cancel. E equals to 1 upon 4 pi epsilon naught Q into 4LR upon R square minus L square the whole square. Since R is very large than L, therefore L square can be neglected. Okay, please copy till this now. Just 3-4 lines more. Okay, completed till this now. Just wait for a moment. We can say therefore E equals to 1 upon 4 pi epsilon naught Q into 4 I am writing 2 into 2 LR upon R square raised to 2. L is neglected. But Q into 2L equals to P equals to electric dipole moment. Therefore E equals to 1 upon 4 pi epsilon naught. This 2L into Q is P into 2R upon R raised to 4. So E will become 1 upon 4 pi epsilon 2P upon R cube, because R upon R raised to 4 will become R cube. Just copy till this, then conclusion wala line will write. Completed till that? 1 upon 4 pi epsilon naught 2p upon r cube.
Yes, sir.
Can you suggest direction of this resultant? Outward, inward, where it will act? This final intensity, where it will act? E1 was inward, E2 was outward. So this resultant is where?
So it's positive, so it will come inward.
This will come inward, okay. Who was greater, E2 or E1?
E2 was greater.
And where was E2 acting?
Outward.
Outward.
So always resultant will be in the direction of the larger vector. No? That means it will be directed outward. Write down below. It is directed outwards. That is along, that is from negative charge to positive charge. In vector form, E bar equals to 1 upon 4 pi epsilon 2. P is a vector. So P bar upon R cube. The angle between E at any point on the axis and P bar is 0 degree, because P is also from negative charge to positive charge. E is also from negative to positive. So angle between intensity on axis and electric dipole moment P bar is 0 degree. This completes our derivation with every format: vector form, magnitude, direction, angle. Yes, completed now.
Yes, sir.
Right, derive expression. Next one. Derive expression for derive expression for electric field intensity at any point on equator of electric dipole. At any point on equator of electric dipole. At any point on equator of electric dipole. Consider electric dipole consisting of equal and opposite charge minus q and plus q at point A and B separated by finite distance 2L, O be the center such that OA equals to OB equals to L. First paragraph. Let P be a point at a distance R from center O on the equator of dipole. Draw AP and PB. Clearly we can see that AP is same as PB, which is root of R square plus L square by Pythagoras theorem. Therefore, this base angle will be congruent because it becomes isosceles triangle. So angle PAB and PBA we can take theta. Consider, again I'm repeating, an electric dipole consisting of equal and opposite charges of magnitude q situated at A and B separated by finite distance 2A. Let O be the center, therefore OA equals to OL equals to L. P be a point at a distance R from center O on the equator. Equator means the line is perpendicular passing through center. Draw AP and BP. Therefore AP equal to PB equal to root of R square minus L square. Let angle PAB equal to PBA equals to theta. Now see, intensity at point P due to negative charge at A will be directed inward this way towards A. This is E1 towards A, and E2 due to positive charge at B will be directed outward from here. ये line सीधा बाहर जाएगा straight. Suppose it is E2. Now if I draw a line parallel to AB, can you tell me what will be this angle? Anybody can say what will be this angle?
Theta.
Theta.
Reason? Alternate.
Alternate angle.
So this E1 can I resolve into two components, horizontal and vertical like this?
Yes, sir.
Yes, sir.
E1 can be resolved into two components. E1 cos theta along horizontal and E1 sin theta vertically downward. Now intensity at P due to positive charge at Q is directed outward as shown. Even this angle is theta, corresponding angle. Correct? No? Corresponding angle. These two lines are
Yes,
parallel,
sir.
transversal, corresponding angle. So E2 can also be resolved into two components. E2 sin theta vertically upward and E2 cos theta along horizontal. This much diagram you all have followed first.
Yes, sir.
Please just draw only
Yes,
the
sir.
theta part. Draw it. Yes, completed full. Diagram completed.
Yes, sir.
Okay, everybody has completed diagram. Pratik, Sanskar.
Yes, sir.
Okay, so let me clear the diagram and start with the theory. See, I'm keeping almost words same so that एक बाहर किया तो दूसरा याद हो जाता है. Consider an electric dipole consisting of equal and opposite charges of magnitude q situated at points A and B at a distance 2L. Let O be the center of dipole. O be the center of dipole. Therefore, OA equals to OB equals to L. Let P be a point at distance R on the equator of dipole. Draw AP comma PB. Therefore, AP equals to PB equals to root of R square plus L square. Let measure angle PAB equals to PBA equals to theta. Copy till this. We have just explained diagram part so far. Yeah, done.
Done, sir.
Now intensity due to negative charge, positive charge, resultant. I'm now completing till end. The intensity at P due to minus Q at A is given by E1 equals to 1 upon 4 pi epsilon Q upon AP square. That is same as 1 upon 4 pi epsilon naught Q. AP is root of R square plus L square. उसका स्क्वायर किया तो ओनली आर स्क्वायर प्लस एल स्क्वायर विल बी लेफ्ट आउट. क्लियर नो वाई? बिकॉज ये रूट में है, उसको स्क्वायर किया तो रूट विल वैनिश. इट इज डायरेक्टेड इनवर्स. The intensity at P due to plus Q at P is given by E2 equals to 1 upon 4 pi epsilon naught Q upon PB square. That is 1 upon 4 pi epsilon naught Q. Even PB is same as AP. So R square plus L square. It is directed outwards. It is directed outwards. E1 comma E2 can be resolved into two rectangular components as shown. Two rectangular components as shown. E1, E2 can be resolved into two rectangular components as shown. E1 sin theta and E2 sin theta. E1 E2 का value same है. So E1 sin theta, E2 sin theta are equal opposite, hence they cancel each other. इतना लिखो, then I'm explaining further. Very simple topic, only it is having connection with previous part. So if somebody is not studying regularly, he or she will not understand. Again, please tell if you have completed full.
Done, sir.
Okay. Now just further see so that till end we can now read. E1 sine theta, E2 sine theta are equal opposite, hence they cancel each other. E1 sine theta, E2 sine theta are equal and opposite, are equal and opposite. Hence they cancel each other. Thus resultant intensity at phi comma E will be E1 cos theta plus E2 cos theta. Since E1 is same as E2, so E will become 2 times E1 cos theta. So E equals to 2. E1 is 1 upon 4 pi epsilon Q upon R square plus L square. Cos theta, if you look in the diagram, what is cos theta? Can you see in the diagram? Cos theta, it is adjacent side which is L upon hypotenuse which is root of R square plus L square, correct?
Yes, sir.
Okay. Therefore, E becomes 1 upon 4 pi epsilon naught Q into 12 upon R square plus L square. ये power 1, इसका power half. So can I write 3 by 2? R square plus L square. First term power 1. R square plus L square. Root means power half. 1 plus half. Can I write 3 by 2?
Yes, sir.
Okay. But P equals to Q into 12 is called as electric dipole moment. Called as electric dipole moment. So therefore E equals to 1 upon 4 pi epsilon naught. E equals to 1 upon 4 pi epsilon naught into P upon R square plus L square raised to 3 by 2. Since R is very large than L, therefore L square can be neglected. Please copy till this. Again 4 pi lines are just pending. Yes, completed.
Yes, sir.
R is very, very large than L, so L square we will neglect. Therefore, L square can be neglected. So E equals to 1 upon 4 pi epsilon naught P upon R square raised to 3 by 2. This power will get cancelled. So it is nothing but 1 upon 4 pi epsilon naught P upon R cube. So intensity at any point on the equator we got 1 upon 4 pi epsilon Q upon R cube. It is directed from positive plus Q to minus Q. Because if you see clearly, this is minus Q, this is plus Q, इसका direction ऐसा result. So plus Q to minus Q. Now can you tell me what is angle between E and P when point is on the equator? When point is on the equator, what is angle?
Zero degrees.
नहीं 180 ना, minus Q to plus Q is P and plus Q to minus Q we got E na. So this is right and this is left. What will be angle between them?
180.
180 degree. So in vector form P and E उल्टा, तो इधर हम लोग माइनस लिखते हैं. Therefore angle between E bar and P bar at equator is 180. Generally we mistake and write sometimes 90 degree. Now completely land. Hello?
Done, sir.
Okay. See, so far we were talking about point charges. Minus Q, plus Q, they were point charges. Point charges means their size was negligible. So every time charge will not be situated at point. Sometimes they are spread or they are continuously distributed. So depending upon distribution of charges, there are three types of distribution. Distribution of charges. So not necessarily every time it will be localized at a point. Sometimes it will be distributed on the surface. First is called linear charge density, denoted by lambda. That means when charge is distributed along the length of any conductor, then it is called linear distribution. So linear charge density is nothing but charge per unit length. It is given by charge per unit length. What will be its SI unit? Charge is coulomb, length is meter, coulomb upon meter. See again what we are telling. Charge may not be every time situated at a point, but they are distributed. Depending upon distribution, I said there are three distribution. First one, linear charge density. So when charge is distributed along the length of conductor, then linear charge density is defined as charge per unit length. SI unit is coulomb per. Okay, meaning clear? Hello?
Yes, sir.
Right. When first write heading, distribution of charge, then linear charge density. When charge is distributed along the surface of a conductor, then linear charge density is defined as charge per unit length. It is given by lambda equals to Q by L. SI unit is coulomb per meter. Hello? 85219 में वो कॉल रखना है 28 पे HDFC. Sorry 1937 874. हाँ 28 पे. हेलो अपना 85219 में 10 ये बर्गर क्यूब लेंगे 10. हाँ ले लो चलेगा. हाँ हेलो टैक्स रेल. हाँ एक और टैक्स रेल TEXRAIL टैक्स रेल. वो 33 में 500 रखना लेने के लिए आया तो ठीक है. एक ही दिन के लिए करना. नहीं पकड़ा. ठीक है ठीक. Completed? Hello, completed this much?
Yes, sir. Yes, sir.
Yes, sir.
Now what is the meaning of this? Suppose this is one straight conductor. Here we are having charge situated on its length. Then that type of distribution is called linear charge density. Suppose I consider very small part of this length dl, on which we assume charge is dq. Then we can say lambda is dq upon dl. Either total charge, total length, or small charge, small length ratio will not change. So just draw this diagram and write this, because in 12th we'll require this dq by dl is also lambda. Done?
Yes, sir.
Second, right? Surface charge density. Surface charge density denoted by sigma. When charge is distributed on surface area A. When charge is distributed over surface area A of a conductor, then surface charge density is defined as charge per unit area. Therefore, sigma is given denoted by sigma. Therefore, sigma equals to charge upon area. Its SI unit is coulomb upon meter square. Right, right point. अभी उसका मिला क्या आंसर बाकी सबको? और वो ग्रेविटेशन का भी नहीं है? नहीं, आप बोल रहे थे ना नया वाले का नहीं है करके। कल नया पेपर एक भेजा था ना, आपने बोला नहीं है। देख लो, नहीं होगा तो फोन करना। फिर उसके बाद अपने को ये संडे का पेपर बनाने का है, मैं आपको बताता हूँ क्या क्या करना है, ठीक है। पहले इसका चेक कर लो, ये है क्या। यस, फिनिश।
Yes, sir.
Okay, so that means here this time charge is on the surface like this. Charge will be on the surface too. So we can say if dA is the elemental area dA, then sigma equals to dq upon dA. So charge dq is sigma dA. Suppose it is sphere, then what will be total charge in terms of sigma? For sphere, area will become 4 pi r square. Hello?
Yes, sir.
Just see carefully what type of surface. I have drawn here any type of surface. So assume the small area dA, which will have small charge dq. So sigma is small charge upon small area. Therefore, dq can be found out as sigma into dA. Draw this diagram and write till this. Okay, done.
Yes, sir.
Third type of distribution, volume, charge, density denoted by rho. Volume, charge, density. If I take, suppose, imagine one sphere or a cube which are non-conducting. Non-conducting मतलब it will not transfer the charge. And imagine मेरे पास एक syringe है, syringe का अंदर पूरा चार्ज भरा है, तो जैसे ही syringe को इधर पुश करूंगा तो चार्ज ये अंदर आ जाएगा. It will not come on the surface because ये कंडक्टर नहीं है, इसके अंदर डिस्ट्रीब्यूट हो जाएगा अंदर. So when charge is distributed throughout the volume of a body, then it is called volume charge density. सरफेस पे आया तो सरफेस चार्ज डेंसिटी, लाइन पे आया तो लीनियर चार्ज डेंसिटी. थर्ड वन, when charge is uniformly distributed in the volume of, किसका वॉल्यूम है, कोई भी सरफेस का वॉल्यूम, वॉल्यूम ऑफ अ body, that means in the space of a body, then volume charge density is defined as charge per unit volume. It is given by rho equals to charge upon volume B. Its SI unit is coulomb per meter cube. Now write this much. Yes, done.
Yes, sir.
Done, sir.
तो 3 टाइप का डिस्ट्रीब्यूशन दिखा, एक सरफेस लाइन पे था, दूसरा सरफेस एक स्पेस का अंदर है. So just draw one diagram. You can take cylinder also, anything you can take. So imagine this is cylinder. Inside this we are having charge. Inside this we are having charge. So therefore rho equals to small charge in small volume. Therefore dq equals to rho d. Just draw this diagram and write this much. So generally if charge is not uniform, we take small part where the charge is almost uniform. This is one of the advantages. Just one part of the chapter left out, that is called line of force, electric flux, Gauss's theorem. तीन चीज, then chapter gets completed. Now I'm clearing this. Last part of the chapter, lines of force. Lines of force, properties of line of force, then a term called electric flux, then last में Gauss's theorem. And Gauss's theorem का application we are having in 12th standard. 12th standard का start is application of Gauss's theorem. See, if this is charge, then what is this space surrounding charge called as?
Electric field.
Correct, electric field. In this electric field, if I place unit charge, they will try to repel this along the line joining the two charge.
Yes, sir.
That means anywhere I place the positive charge, it will repel along the same line, along the line joining. ऐसा कितना line हो सकता है? Infinite हो सकता है ना, बहुत सा line है ना. So these lines, they are actually called line of force. So I can say the path traced by unit positive charge. The path traced by unit positive charge when placed in an electric field is called as lines of force. So path traced by unit positive charge when placed in electric field is called as lines of force. Please write down. Chalo, done.
Yes, sir.
Next heading. Properties of lines of force. Properties of lines of force. Around 8-9 properties we are doing. In exam they can ask you any 4 first. This is which charge? Positive or negative?
Positive.
This one? Negative. So it is assumed that line of force, they start from positive charge and terminate in negative charge. The line of force was path traced by unit charge, positive charge. From current I know direction of current is from positive to negative. तो ये पॉजिटिव चार्ज मतलब करंट ही होता है ना इनडायरेक्टली इफ इट इज मूविंग. तो इसलिए एक एजम्पशन बन गया ऐसा, लाइन ऑफ फोर्स दे ओरिजिनेट फ्रॉम पॉजिटिव एंड टर्मिनेट इन नेगेटिव. रिटर्न नहीं आएगा, टर्मिनेट हो जाएगा. So it is not closed curve, it is always open curve. So first property, the lines of force always originate, or you can say start, originates from positive charge and terminates in negative charge. Originates from positive charge, terminates in negative charge. Right, first one. First point done.
Yes, sir.
Suppose this is conductor and here we have positive charges. So line of force will be starting from this positive charge, but always perpendicular, not inclined. If it is negative charge on the surface, so inward आएगा, but perpendicular. Spherical surface है, तो radially outward or radially inward, so that it becomes perpendicular. Positive outward, negative inward. So second property, lines of force are always perpendicular to the surface. Always perpendicular to the surface. Right, second point of conductor. Always perpendicular to the surface of conductor. Lines of force are always perpendicular to the surface of conductor. Done?
Yes, sir.
Third point. Suppose this is positive charge, this is negative charge. Line of force are starting and terminating. At particular point, if we want the direction of the field, then we draw tangent, tangent, tangent. Projectile motion में also we did. When you throw the body obliquely in air, ये point पे direction के लिए tangent चाहिए. So third point, tangent drawn at any point on lines of force represents direction of electric field at that point. Electric field at that point. Tangent drawn at any point on line of force represents direction of electric field at that point. Copy. Done.
Done.
See, if this is line of force, you can't have another line of force cutting this, because if line of force intersect, then at one point we have two direction of field. मतलब I have two tangent, एक इसको बना सकता हूँ, एक इसको tangent बना सकता हूँ. अभी चार्ज या तो ऐसा जाएगा या तो ऐसा जाएगा, unless until this breaker. In some South Indian movies, they will show one bullet is coming out, it will spread into many parts, hit the target, come back to the hero's pocket. But practically it is not true. So line of force they do not cut. If they intersect, तो एक जगह पे फील्ड का दो डायरेक्शन, फील्ड का दो डायरेक्शन मतलब मोशन ऑफ चार्ज दो डायरेक्शन में. See, either something will move like this or something will move like this. वो अकेला इधर और इधर दोनों डायरेक्शन में तो नहीं जा सकता है ना. So it is not possible. Therefore we get fourth point. Lines of force never intersects each other. If they intersect, then we have two direction of field at the same point, which is not possible. If they intersect, then we have two directions of field, which is not possible. Right, fourth point. Lines of force never intersect each other. If they intersect, then we have two direction of field, which is not possible. Okay, done. Huh?
Yes, sir.
Fifth point. ये simple है to understand. Lines of force can elongate. On this basis, repulsion between like charges can be explained. Like charges they repel, इसका मतलब बीच का line of force has elongated. Lines of force can contract also. That means they have lateral push-pull ability. Contract. On this basis, attraction between unlike charges can be explained. Right, 2.5 and 6.
Done, sir.
Okay. Seventh point, they can pass through insulators. सही पॉइंट है, बट नॉट थ्रू कंडक्टर, बिकॉज कंडक्टर में पास हो गया तो करंट इलेक्ट्रिसिटी हो जाएगा. So they can pass through insulator but not through conductors. That means if this is insulator then I can show line of force ऐसा, but if it is conductor तो ऊपर खाली होएगा, अंदर नहीं आता. Right. 7th point write down. 8th point, they are crowded at the place where intensity is maximum. मतलब अगर बहुत ज्यादा एक ही जगह पे देखा तो strength is more. Like if this is one surface, मुझे ऐसा ऐसा दिख रहा है फील्ड लाइन, दूसरे सरफेस में ऐसा 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 दिख रहा है जगह पे, तो ये मैक्सिमम वाला, ये मिनिमम वाला. मतलब ज्यादा स्पेसिंग मतलब वीक, नजदीक नजदीक यानी कि स्ट्रॉन्ग. दे आर क्राउडेड एट द प्लेस वेयर इंटेंसिटी इज मैक्सिमम. Now nearly just 1 hour topic is left out in theory that will complete the chapter. So next class we will complete the chapter and start with numerical. And one lecture will take on again coming Tuesday to complete MCQ. So coming Tuesday our chapter will get over. After completion of this I will start magnetism, and after this I will start with light. फिर उसके बाद एक ही चैप्टर बच गया पार्ट 2 में. पार्ट 2 is starting from light. That's all for today. Let's meet on Saturday. If there is test